From chapter 4, I'm going to be balancing the equation. So here we have sucrose, oxygen, carbon dioxide, and water. So how I like to do it is I set it up with each of the elements in the reactant and the product side. So we have C, carbon, hydrogen, and oxygen. And on the reactant side, there are 12 carbon, 22 hydrogens, and 13 oxygen. And then on the product side, there are, so on this side, there's only one carbon, so we are going to balance it out and try to make 12 carbons. So luckily it's 1, we just need to multiply it by 12, which will give us 12 evidently. And then we're going to move on to hydrogen, which on this side there are 22. So we'll just multiply this by 11 and we'll get 22. And now here's where it gets a little like a little bit tricky, I guess you could say. Is because there's only, because there's 3 oxygen on this side and 13 on this side, and you can't really multiply anything by 3 to get. So the 13 oxygen on this side becomes from the 11 over here, and then the 2 right here. So to try and make this even, what we're going to do is multiply this oxygen by 12, which will give us 24. So then we will have 11 plus 24 because we just are multiplying that 12 by 2, which will give us 24, which will equal 35. And then if we go back on this side, I forgot to mention this earlier, but this 12 goes right here. So there's also so that's where there's the 12 carbons are coming from on the product side. And then for oxygen, we'll have 24. And then that 24. And then also since we multiplied hydrogen, we did the 2 times 11 to get 22. The 11 goes right here. So we're going to add 24 plus 11 to give us a grand total of 35. So now we have our balanced equation. From chapter 5, our question is, calculate the molarity of a solution by dissolving 32.2 grams of calcium carbonate in enough water to form 150 milliliters of solution. So we just need to set this up by saying, so we have the moles of solute over liters of solution, and what you're going to want to do is take the 32.2 grams of calcium carbonate and multiply it by 1 mole of calcium carbonate over the molar mass of calcium carbonate, which is 100.0869. And then when you plug that into the calculator, what you will get is 0.322. So then once you get that, you're going to want to focus on the liters, the 150 milliliters of the solution. So you do 150, and you're going to want to convert this to liters. So you're going to need to multiply 1 liter over 1,000 milliliters, which will give you 0.01150 liters. So then once you get these two numbers, all you have to do is plug it back in to this. So you do the 0.322 over 0.150 liters, and then you get 2.15. And that's your final answer.